Today, we're going to learn to graph sine and cosine waves. You did learn this last year in Algebra 2. We're going to do more detail. This is a really important topic. And the kind of word problem version of this is one of the open responses on the AP exam. So again, very, very important. So we're going to do it the long way first, and then we're going to learn the shortcut. So we're going to draft the parent functions of sine of x and cosine of x by making an xy table and graphing by connecting the dots like we always do to start off. I'm going to do this kind of quick. So to get a full cycle or a full period, we're going to go from 0 to 2 pi, and we're going to list angle measures of multiples of pi over 4. So that would be 0, pi over 4, pi over 2, 3 pi over 4, pi. That's 4 pi over 4, 5 pi over 4, 3 pi over 2, because that's 6 pi over 4, 7 pi over 4, 8 pi over 4, which is 2 pi. And then we're going to remember those because we're going to use those all the time. So you know from our previous lesson that the y values, so sine of those angles, are 0, square root of 2 over 2, 1, square root of 2 over 2, 0, negative square root of 2 over 2, -1, negative square root of 2 over 2, and 0. And for the sake of graphing these in the correct place, this is approximately 0.7. So is this. This would be negative 0.7, and this would be negative 0.7. So if we plot these on the graph, and I multiply every one of the darker lines as a multiple of pi over 4, and they sort of line up with where these are in the box. So I'll label these super quick. And then we start graphing. So we get an output of 0, and I'll call this 0.5, and this is 1, and likewise. So 0.7 is here, and then we get 1, and then we get 0.7, and then 0, and then negative 0.7, negative 1, negative 0.7, and 0, and connect the dots with a nice smooth curve that looks like an ocean wave. And notice that at the end, we've gotten back to where we started from. So now we're going to do the same thing for cosine of x. So I want you to pause the video, fill in the same angle values in the top row, and then fill in the correct output values down here. And then you're going to want to do the approximation for the square root of 2 over 2 values with the 0.7. So pause the video and then take a look to see if you got those correct. So this is what you should have. And then you're going to label the horizontal axis on the graph the same as we did above for the sine wave, plot those points correctly, and connect the dots. So pause the video and do that. And when you're ready, start it and take a look. So this is what you should have for your cosine wave. So let's look down here. Here they are again. So this is sine and cosine. So let's see which is which. So the sine wave, when x is 0 or the input is 0, the sine wave starts its wave kind of in the middle of the wave. And so that's what's going on with the green. So this green here is sine of x. And cosine waves, so the parent graph, starts at the peak of the wave, and then it heads down toward the middle and then the valley. So this red one is cosine of x. And hopefully you can tell that they're the same shape. They're just shifted horizontally from each other. So that's always true. right, here's a definition. The period is the distance, so horizontal, for the function to complete one full cycle and then repeat. So if we look at, say, the cosine wave, for example, if we start at x equals 0, when have we completed a full cycle so it starts repeating? Well, it's when we end up back over here at the peak again, and that's a horizontal distance of 2 pi. So the period of both sine x and cosine x are 2 pi. So now we're going to start doing some transformations. We'll do a whole bunch of transformations and then we'll be really good at this. So we are going to graph all of these on the same graph. So the first thing is we take a look at all the things we have going on and we decide what scale to make on the horizontal and vertical axis. So the parent graph, we already know what that looks like. This is a vertical reflection. We know this from previous information. This is a vertical shift. We know that from previous information. So we're going to go up 2. This is a vertical stretch. This is a vertical shrink. So I know I need to have the ability to stretch it a height of 2 more than it was. And I also need to be able to shift it up 2. So let's make our vertical scale go up to 3. So 1, 2, 3, evenly spaced as always. And notice, well, you won't notice, but anyway, the period, I'll do the same thing where I go out to 2 pi. And then you hopefully noticed that when we did this before, but let me point it out because I didn't explicitly say it. This is a nice systematic pattern here. So halfway through the cycle, so halfway, so the period was between 0 and 2 pi. So halfway we got like obviously half of the graph, but for the sine wave, we get the top part of the curve. And then for the second half, we get the bottom. For the cosine wave, we get from the peak all the way down to the valley, and then we get the second half. So turns out every fourth of the period is a point that I'm going to call a special point where we can tell. So a middle, a peak, a middle, a valley, a middle, a peak, a middle, a valley, a middle, a peak. So we're going to divide this into fourths because every fourth something important happens on the wave. So halfway is pi, halfway here is pi over 2, halfway here is 3 pi over 2. So those are important. So speedy quick, we're going to graph cosine of x, which we already know what it looks like. So cosine starts at a peak and then it goes middle. And then valley, notice my amplitude, my height of this is 1. This is the parent graph, middle, peak. I know it looks shallower than before. It's because we changed our scale. So that's the parent graph. So now we're going to graph a reflection. So this is a vertical reflection. Anything done in Y outside on the whole thing is vertical. So it's going to reflect across the x-axis, meaning down. So everything is going to be the opposite side of the x-axis. So I'm going to start below and hit the middle and hit a peak and hit the middle and hit a valley. Hopefully, when you look at that, that looks like a vertical reflection. Then let's look at this one. +2 is a vertical shift. So that means the entire blue graph is going to just be picked up and plunked down 2 units higher. So now let's talk about a definition here. This is called the sinusoidal axis. So it is the horizontal line about which these functions are symmetric. So that sinusoidal axis for this green function is going to get moved up 2 units. So on the parent graphs, the sinusoidal axis, the axis of symmetry is at y equals 0. So this is going to move up to 2. And then nothing else has changed on this. So I'm going to start at a peak, midline, valley, midline, peak. and then we connect them, and hopefully you can see that the green is shifted to up from the blue. Now let's look at this one. We have a coefficient of 2 multiplied on y on the whole thing, so that's a vertical stretch. So the whole thing gets taller by 2 units. So we multiply all the y's by 2. So I'm looking at my blue, and all my y's get multiplied by 2. So the peak is going to be at 2. This height is 0, so 0 times 2 is still 0. This height is -2, so, sorry, -1 times 2 is -2. So peak, middle, valley at 2, middle, peak at 2. And hopefully you can see that the pink is the same shape, but stretched taller. And then lastly, here we're multiplying by 1/2. That should be a vertical shrink. So the maximum height, instead of being 1 on the parent graph, is going to be 1/2. So peak, middle, valley at 1/2, middle, peak at 1/2. So same shape, but vertically compressed. And now let's look down here. I've got a summary of everything. So if you have a function in this form, we've got several coefficients in here. So A gives us the amplitude, so height from the midline, which is called the sinusoidal axis. Or you can think of it as 1/2 of the difference between the maximum and minimum heights. The period, so the horizontal distance it takes to make a full cycle is 2 pi over b. So there's the b. C is a horizontal shift, which we didn't do and we're not doing that today. And adding something onto the whole thing is always a vertical shift. And don't forget that if you have a negative in front of the function, that would be a vertical reflection, just like it always is. And then here's my method. So you should go back and reference this as we're doing things, but I'm not going to read it to you. We're just going to reference this every time we make a graph. So we're going to graph all of these on the same axis. And the first thing I'm going to do is decide on my scale, so all of these will fit. Parent graph, we know what that looks like. Here, I'm going to check out the period of all of these. So the period is, that's B, is 2 pi over B, which is 2. So the period is pi. So this is going to be horizontally compressed. And then here, B is 1/2. So the period is going to be 2 pi divided by 1/2, which is 4 pi. So that's going to be horizontally stretched. So I have to make my x-axis, it's compressed, but it gives me more values. And here my period is going to be 2 pi over 3. That's B. Notice that all of these do not have a coefficient other than 1, but this one does. So that is going to be a vertical stretch. So that means my amplitude is 3. So I need my y-axis to go up to 3 and down to 3. And then there is, the B is 1. So the period here is, I'll write it down because we're going to use it later, is 2 pi. There's no change compared to the parent graph. And we get shifted down 1. And the amplitude is 2. So I know I need to go out to 4 pi. So this will be 2 pi. And I know I'm going to need fourths here, so I'll fill them in now. So pi over 2, 3 pi over 2. I'll fill in the rest later. My biggest amplitude is 3, so I'm going to go up 3, 1, 2, 3, down 3. All right, here we go. So let's graph sine of x first. So super simple, we're going to do it really fast. The period's 2 pi, so we're going to finish the cycle here. Sine starts when x is 0, the height is 0, and then these are the fourths. So pi over 2 pi, 3 pi over 2, 2 pi. So we go middle, peak, middle, valley, middle, connect them, and that's sine of x. So we're going to have these fully memorized because we have to do this over and over and over and over. So the next one we're going to do is sine of 2x. So the only transformation compared to the parent graph is that the period changed, and the period is going to be pi. So I want to split this into my fourths. So if you look back at the notes at the bottom of the previous page, I suggest finding the fourths. So that would be pi over 4. And then let's list out where those fourths land. So we're starting our cycle. There's no horizontal shift at 0. And then we're going to go pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. I simplified as I talked, which I don't always do that well, but I did okay. So the pi over 4s are going to be like this. All right. So for this function, we're going to start at a midline, peak, midline, valley, midline, and that's a horizontal shrink compression. All right, now let's move on and do this one where there's a horizontal stretch. So the period is much longer. So let's do the fourths again. So we take the period and divide it by 4. So the fourths happen every horizontal distance of pi. So let's list them. So notice there's 1, 2, 3, 4, 5. That's because you start somewhere and then you go 4 horizontal distances that are a fourth of the period. So we're going to go 0, pi, 2 pi, 3 pi, 4 pi. Always just adding pi each time. So we'll do this one in yellow. So I have 1 pi, 2 pi, 3 pi, 4 pi, and we'll start at a middle. And my amplitude is still 1. Peak, midline, valley, midline. So it looks like this. Great. Now let's move on to 3 sine of 3x. So the period is different and the amplitude is different. So let's figure out the fourths. We'll do the amplitude. We'll deal with the amplitude later. So the period we know is 2 pi over 3. So the fourths are 2 pi over 3 divided by 4. So that would be pi over 6 if you simplify it. And if I list the fourths, they would be 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. All right. I'm going to have a hard time squeezing that in here, so I'm going to make a new graph below, and I'm going to remember that I need to label that my amplitude goes all the way up to 3. I'm not going to try to squeeze it on here. So go ahead and do that, pause the video, see how you did, and then turn it back on when you're ready and look below and see if you did it correctly. So how did you do? So we've got our fourths, pi over 6, pi over 3, pi over 2, 2 pi over 3. Don't forget the amplitude is 3, so midline, peak, midline, valley, midline. Wonderful. So now let's look at the last one. For this one, we calculated the period. We know that it's a shift down and that the amplitude is 2. So again, pause the video, graph this wave. And then when you're ready, unpause the video and look and see if you did it correct. Right, so there it is. So we went down. So we started at the midline at -1. I drew in my sinusoidal axis there, midline, peak, midline, valley, midline. And now we're going to turn